hanging in there for this session, Personalizing the Cosmos. My name is Mary Dussault, and I'm a Science Education Program Manager at the Smithsonian Astrophysical Observatory. I'm joined here by my colleagues Erica Wright and Grant Tremblay, who will all give a short informal introduction of ourselves in just a little bit. But first of all, I want to say a little bit about our institution, the Smithsonian Astrophysical Observatory. Next slide, Grant. We are one of the research centers of the Smithsonian. All of Grant, Erica, and I are all staff at the Smithsonian Astrophysical Observatory, which is not in Washington, D.C., but actually is co-located with the Harvard College Observatory and the Department of Astronomy at Harvard in Cambridge, Massachusetts. And scientists and engineers at the observatory study the universe using telescopes in space and on the ground. The NASA's Chandra X-ray Observatory is actually operated by scientists from the Smithsonian, and scientists study the universe from nearby, from understanding the sun and its impact on the Earth to understanding the farthest galaxies. And in a little bit, you'll get a tour and hear some of the stories that all those objects bring us about the universe. I think we're going to let Erica give an overview of our agenda today. Erica?
All right, thanks, Mary. So to give everyone an idea of how we'll be spending the next about an hour or so, I just want to go over the agenda real quick. So we're going to start with our introductions, not just who we are, but a little bit about our personal connections to the night sky. And then we'll take a few minutes to hear about your star stories as well. After that, we're going to hear some stories from the cosmos as Grant takes us on a tour of the universe. And following that tour, we'll wrap up our session with some resources that will help you and your students find your place in the universe and tell you a little bit about the education research we're also doing at the Center for Astrophysics. So I think Mary's going to kick us off with her introduction and star story.
Thanks, Erica. So just a description of me on the screen for our blind and visually impaired colleagues. I'm a white cisgendered lesbian woman. I am currently wearing a white blouse with black buttons, and I have glasses with red frames. And a little bit about how I got to the observatory and my a personal connection to the cosmos. The image pictured on the screen here is a favorite object in space of mine. It's called the Hercules star cluster, or M13, after the astronomer Charles Messier, who cataloged a whole bunch of objects from 1 to 110. This is the 13th. I first learned about this object as an undergraduate when I thought I was going to major in chemistry, but took an astronomy course and fell in love with the universe. And this was the first object I ever took a photograph of using a telescope. Now, this isn't the photograph I took because back then I was in college long enough ago that we actually had to use film at the focal point of the telescope, and it took a long time to expose that film, and I had to expose it in a dark room. And these two images are amazing to me because they demonstrate the growth of astrophotography, of technology, and taking images of the universe. The one in the background is an amazing image of this star cluster from the Hubble Space Telescope, which everyone knows about, brings us amazing full color images of the universe. And the one in the foreground is actually an image that I created using educational tool that we'll be talking to you about later, our micro observatory robotic telescopes. And it's an image that any of you or your students could make as well. So that's the personal connection I wanted to talk about. Erica?
All right, thanks. So my name is Erica Wright, and I'm an education specialist at the Center for Astrophysics. And just for a quick visual description, I'm a white millennial woman with long brown hair. I'm currently wearing a white shirt and blue framed glasses, and I'm sitting in front of a plain yellow wall with a framed topographical map, actually. So I came to my role at the Center for Astrophysics with a less traditional background for a place that studies the universe. My degrees are in biology and museum education. So although my formal schooling focused on things like plants and DNA and how I can help others to learn new things and get excited about new topics, particularly in my case, science, I've always had a love for the night sky. On the screen, you'll see an image of the night sky during the Perseid meteor shower. It's framed by a few trees, and there's quite a few stars in the evening sky, and you can even see a few meteors. So this actually reminds me of a very personal story from my childhood. I have very fond memories of as a young child on the top of a local mountain, actually in that topographical map behind me. Every summer, family friends would travel to the top of this mountain at dusk, and we'd hold a barbecue. And after filling ourselves with hot dogs and hamburgers that we roasted over an open fire, we'd lay down blankets on the top of this mountain and stare up at the sky. And there you'd see the most beautiful show that the night sky can put on. They were always timed for the height of the Perseid meteor shower. So on the top of this very rural mountain, we'd get to see hundreds in an evening of meteors or of stars. And it was just the most beautiful experience that I've ever imagined. And although it's not my only fond memory of the night sky, it's one that's constantly sticks with me and has a really special place in my heart. And it's one of the things that has drawn me to the night sky. So I'll let Grant tell you his star story.
Okay, thank you, Erica. Hi all, my name is Grant Tremblay. It's an incredible pleasure to be here in front of so many educators. For our visually impaired colleagues, I'm a white 37-year-old cisgender male. I am sitting in front of a virtual background of a painting of one of our great observatories, Chandra X-ray Observatory, which we operate here at the Smithsonian. And I have this virtual background up because I'm sitting next to my 3-year-old daughter who might wander past me at some point. This is the perils of giving talks from home. Look, I have a difficult job in that Erica and Mary asked me to give you a tour of the cosmos in a personal way. And that's a challenge because the cosmos is so inconceivably vast. And so this is one of the reasons why this is one of my favorite pictures. I happen to take this picture, so it has a personal connection to me. I used to work before I was at the CFA at a giant observatory in the Atacama Desert in Chile. It's called Paranal Observatory. We have one of the world's largest and most powerful telescopes in the world there. It's called the Very Large Telescope. And this is a picture that I took from the VLT platform about 10 minutes after sunset, so civil twilight. It is my favorite time of day. And one of the reasons why it's my favorite time of day is because you can see night start to encroach upon the earth. And that encroachment is actually done by the shadow of the earth itself, right? So I'm showing an image, that's a video of an image of a purple sunset. But in the right-hand side of this image, you can see this dark triangular band. And that is literally the shadow of the earth itself as the sun is setting behind the horizon. And it's one of the incredible ways that I can think of to connect the scale of the earth to humanity and then the scale of the earth to the cosmos itself. So I'll talk more about that in a little bit, but I do want to move on to our introduction to our stories.
So now it's actually, this is the participatory part of this session. We are going to ask everyone who's joined us to go to a Padlet to tell your own connection to the cosmos. And really, even if you don't think you have one, everyone has some kind of personal connection to the universe, whether it's in your language, the very days of the week that we talk about in English, Sunday, Monday, in Spanish, lunes, martes,
Miércoles.
Miércoles, thank you, Mercury, yes. So in the very language that we speak, the universe is part of it. So when you get to that Padlet, if you go to the link, it should be in the chat now in the event on the right. And if you copy and paste that into your browser, you'll see from an earlier version of the session, we actually have a lot of people's cosmic connection, but try to think of some story where where space or the universe had some personal meaning for you. And this is an activity we often do with students or with educators. And it's a way of kind of really reflecting on bringing meaning to an exploration of astronomy. And there's a lot of amazing stories already on the Padlet, and we'd love to hear yours. In order to add something, by the way, if you haven't used a Padlet, there's a little plus in the bottom right of the screen. And if you click there, you'll get a little window that opens, and you can type into it. You can upload a picture into it. You can do a Google search and find something that means something to you, if it's a and then post it. So we'll offer some wait time here to see if we get some additions to our cosmic moments. I love that an earlier educator has named their dog Hubble. They are so fascinated by space.
I love it.
I love it. And someone has posted that they viewed the July 2018 lunar eclipse. Was that 2017? 2018 on a trip out west.
Yeah, it's 2017.
Yeah.
The total,
Or-
the lunar eclipse. Sorry,
eclipse.
not the solar
okay,
eclipse.
the solar eclipse. Yeah.
Okay, yeah, 2018, yeah.
Great. A fifth grade outdoor education trip where the principal introduced me to constellations. It was life-changing. I went on to study education and astronomy. We have an astronomer online with us. Okay. Oh, and now we have multiple people starting to post. Excellent. Saturn's rings at 3 a.m. when I was in 4th grade. A lot of these, I like, they involve some relationship. You were with somebody experiencing something in space. It's so wonderful. Halley's Comet in 1986. And vacations with dark night skies. That's often a lot of time. Very few of us get to live under dark night skies anymore. So that's often a great connection. Well, these are great and really help kind of start to show how exploring the universe can have some personal meaning. And right now we want to give you a chance to hear about what Grant finds really amazing about the stories of the universe that he's learning about.
Yeah, okay, thanks, Mary. Yeah, it's a tough job, but in some ways it's easy because my very first personal connection to the cosmos was given to me as a gift via an educator, right? It was Miss Bowen, my 7th grade junior high school science teacher, and she just completely inspired me. And so I have quite literally my entire career, and in many ways my life, in thanks to educators like you who inspire students every day. And I'm really, really grateful. And I'm really, really lucky. But I also have a very difficult job because Mary and Erica asked me to personalize the cosmos. And if I could tell you one thing to try to drill into your students' heads, it's that the universe is incomprehensibly vast, right? And the emphasis isn't on the vastness, not on how big it is, but in how incomprehensibly vast it is. And there's a reason for this, right? So we human beings are visceral, tactile creatures, right? And we can appreciate scales only up to a certain limit, and it's pretty small, right? So I'd argue that the largest physical structure that we as human beings have a visceral appreciation for is maybe something like a skyscraper, right? You could walk into the lobby of a skyscraper and walk up the stairs to the top floor, take you a long time, it'd be exhausting, or you could take the elevator and it's a long ride. And you look out of the window of the top floor and you start to get an appreciation for, wow, this is a big structure that I'm standing upon, right? And as soon as you start to get beyond these scales, we start to lose that visceral connection, right? Say you're at this altitude in a helicopter over London or something, right? And things start to get a little bit more decoupled from your sense of scale, right? The people look like tiny little ants. The buildings don't look real. Everything starts to look gauzy, and we start to lose appreciation for it, right? Now, we have some chance, right, in that you can ask your students if they've ever been on a plane, right? And who's on a plane anymore nowadays, but a lot of us have been on a plane, and a lot of your students will have been on a plane. And one of the best ways for a human being to appreciate the scale of the Earth is to be at 40,000 feet in a plane and looking out of a window on a very crisp, clear horizon. Because just about at 40,000 feet, you can just about convince yourself that you start to see the curvature of the Earth. And one thing that human minds are very good at doing in general is drawing circles in our head, right? So if you start to see the curvature of the Earth, you can mentally start to draw a circle, and you realize how large that circle would be to encompass the entire Earth. And then you start to get an appreciation for it, right? But that is just about our best chance of comprehending a scale of a cosmic object, right? And a terrestrial body like the Earth is a really tiny cosmic object, right? So one of the things I hope you'll do with your students, if you're ever teaching them anything related to our cosmos or our solar system or our story in the cosmos, is to talk about our farthest reach in our solar system, right? So giving them a little history lesson, because if you know, the Apollo days when we set foot on the moon, that was closer to World War II than it is to now, right? And it's starting to fade into the ether of history, right? So tell them about our rich history in low Earth orbit, right? At this very moment, there are 14 human beings in low Earth orbit. That is a world record for the most number of human beings in any time in all of history. This is because we have 7 human beings on the International Space Station. We have 3 on the Tiangong Space Station, the Chinese space station. And we have 4 astronauts, newly minted astronauts on the Inspiration 4 crew on a Dragon capsule launched by SpaceX quite literally yesterday, right? And they'll be in orbit for 3 days. So this is now the time when we have the most number of human beings in low Earth orbit, right? But we've been further than that, right? And some of your students might not know much about the Apollo program, right? Because it was a long time ago. This is one of my favorite images ever. This is an image taken by astronaut Al Worden as Apollo 15 was leaving the moon, as they were returning home. This is an image of the Earth suspended in a sunbeam taken by a Hasselblad UV camera from the Apollo 15 command module on their way home. So please do tell your students about the incredibly rich history of not only the US space program, but also, for example, the incredibly rich Soviet space program. Go Google the Soviet Venera stories, the story of the Russian landers on Venus. And it is just a mind-boggling story, and I hope you tell your students about it. But you can also tell them, as you're reviewing the sort of history of the spaceflight program around the globe, you can ask your students, how far do you think a human being has ever been from the surface of the Earth? And the answer to that question is, it's in this image right here, right? So we were operating on a little bit of a delay, so normally I'd poll the audience, but I'll just spoil it. And the answer to the question of what is the farthest a human being has ever been from the Earth is this. As you might remember, the Apollo 13 mission suffered a very dangerous catastrophe. Thankfully, no one was harmed, but it was a very dangerous situation. They could not land on the moon, and they had to initiate what's called a free return trajectory that slingshot them around the moon. They couldn't land, and they had to book it back to Earth to survive. And because they initiated this special burn around the moon, as they hit the dark side, they had an apogee, or furthest distance from the Earth. That is indeed the largest distance that a human being has ever been from the surface of the Earth, 248,655 miles on 15th of April, 1970. It is a record that has never been beat, and frankly, will never be beat for a very, very long time, potentially decades, right? But this is not the full image, right? So let me zoom out. This is the actual full image, right? Now, on your internet browser, this you probably don't see much, but the Earth and the moon are in the top right corner, just tiny little specks. And part of this same image in the bottom left is a planet that we all know, Jupiter, the largest planet in the solar system, one of the most beautiful planets in the solar system. And you can even see 3 little dots. You can see 3 of its 4 large moons, Io, Europa, Ganymede, and Callisto in this image. I'm going to poll the audience, and you can just guess in your mind. We're not going to have time to wait for an answer, but where was this image taken from? And the answer is the orbit of Mars. This I've faked it a little bit. This is not a full image. This is a composite that I put together. But this image was indeed taken from the orbit of Mars, from a satellite called the Mars Global Surveyor. It's no longer operating. But satellites like this orbit Mars even now. One of them is called the Mars Reconnaissance Orbiter, and indeed they're meant to look down at the surface of the red planet. And this is one of those images, right? And this is another one of those images, right? So every once in a while, the Mars Reconnaissance Orbiter and Global Surveyor will see this tiny little glint of light on the surface. It looks like a metallic object. And if you can guess what it is, you're probably right. This is the Curiosity rover. We have a new rover on Mars now called Perseverance. This is Curiosity. It was landed on Mars around 2011. One of my favorite images that Curiosity has taken are these sets of images that I'll show you next. This is twilight in Gale Crater, where Curiosity is currently sitting as we speak. The sun is upsetting, right? So here is an actual real image of a sunset on the surface of Mars. You can notice that the angular size that the sun subtends in the sky is much smaller because Mars is much further away from the Earth. So sun setting, right? Now the sun has set behind this mountain ridge. And as it gets darker in the Martian twilight sky, stars come out, right? And you can I bet you can barely see this on your screen, but I'll point it out in a second. You can see some stars in this image if you look really close. But one of them is not a star, it's the Earth, right? Our entire civilization in that tiny little dot of light in the Martian sky, 55 million miles away. Every human being who's ever lived, every animal, every trace of bacteria, on that tiny little dot, right? So this is one of our farthest reaches in the cosmos. Maybe one day a human being, maybe one of your students will set foot on the surface of Mars. I hope so. I really hope so. But we've gone further than that with probes, right? This is one of my favorite missions. This is, of course, a fake CGI video of a mission called Cassini. Let me just show you some real imagery from Cassini. Cassini orbited the Saturn, of course, for many, many years. It was a spectacular mission, very complicated orbit, did many close passages to Saturn. All that you're seeing right now is a 100% real image. This is a movie stitched together from real images. Nothing is fake, nothing is enhanced, nothing is CGI. Everything is completely real. And I personally love this movie because it just shows, one, what a spectacular planet Saturn is, but two, what an incredible journey human-made objects have had in the solar system. And can you just imagine, you know, the Cassini in 2016 ended its mission. It entered the upper atmosphere of Saturn and vaporized and was crushed by the atmosphere. But just imagine, you know, a human-made object, just the traces of it, even the vapors of it are now in the atmosphere of Saturn for all time. And it's just incredible to think about. So Cassini took this image. This was a very special image. So Saturn looks a little weird here because it's directly backlit by the sun. So the sun is directly behind Saturn here. The reason you see the rings look funny, the rings that are co-spatial with Saturn, that's because you're seeing reflection off the surface of the rings back onto the planet. And I bet, again, that you can't see the stars in this image, but there are stars in this image, and there are things that are not stars, and I'll point them out right now, right? So the small text are large moons of Saturn: Mimas, Prometheus, Enceladus, Tethys. But Mars is in this image, it's up there, and Earth is in that little box right there. There's home, there's our planet from 900 million miles away, right? Everyone who's ever lived. It's an incredible image. Cassini did other things, right? On it, it piggybacked on it when it launched was a small landing probe called Huygens. It landed on the surface of Titan, which is a large, incredible moon of Saturn. This is what it looks like. It looks featureless, right? And that is because Titan is enshrouded in this very thick, opaque atmosphere of methane gas. And so you can't see the surface. But if you look in the infrared, as Cassini could, you can see actual literal oceans of something on the surface. Is it an ocean of water? You know, probably not, right? It's really, really, really cold out at the distance that Saturn is from the sun, right? But what you can see is sun glinting off the surface of this liquid ocean, just like we see sun glinting off our oceans as you look out, you know, on the shore or out of an airplane window. You can see sun glinting off of this lake or ocean or whatever it is. So what is it, right? Huygens landed in this area of Titan. This is real descent imagery. This is the actual lake that Huygens was falling toward. It had a parachute. It's about the size of Lake Superior, one of the Great Lakes. It's a huge, right? This is real descent imagery of a real alien world. It landed and took this image, right? And this is an incredible, one of the most incredible images in all of human history. And it doesn't look like much, but you got to appreciate it, because this is the sole image sent back by Huygens, the most distant human-made object on the surface of another world. And it will be for a long time. It transmitted for about 90 minutes in almost complete darkness. So this image, it looks like you see some light. It was almost totally dark on the surface of Titan because the atmosphere is so thick that barely any sunlight gets through. And so this is an infrared image and almost like night vision. And so this image, imagine it being totally dark and minus 291 degrees Fahrenheit amid a light rain shower of liquid methane, right? So that lake that I was talking about is not water. It is a lake of liquid methane, literally liquid cow farts, right? And that is just incredible. It's one of my favorite images of all time. And I hope that one day you show it to your students. It's something to really appreciate. And just think, even it's not transmitting anymore because the electronics have long since failed, but it is still sitting there on that lake shore, right? Right as we speak right now. So how the farthest that we've reached out, what's our farthest step into the cosmic ocean, right? If Earth is a beach and this just boundless cosmic ocean is the rest of our cosmos, how far have we stepped out? Have we gotten in a rowboat and started, rowing out there, or just have we put a toe in, right? So the answer is really the Voyager 1 and 2 and Pioneer 10 and 11 probes. Voyager 1 and 2 are two of the most distant human-made objects, and they basically always will be unless we build something really, really fast to catch up to them. But don't forget, they've been traveling away from the solar system since 1977. Affixed on one of them is something called the Voyager Golden Record, and this is meant to be an archive of our civilization, right? And don't forget, it was 1977. Kids nowadays will go to Starbucks and take 200 pictures with their iPhone. But back then, we could only fit 116 images encoded in an analog record on this record. It looks like this. It has glyphs on the front for a 1 in a trillion chance that some alien civilization in 300 million years wanders by this derelict artifacts floating in the void. These glyphs are, I don't have time to describe all of their meaning, but one of them is the 21 centimeter transition of hydrogen. One of them is the location of the Earth relative to 14 local pulsars. Just incredible things like that. This was designed by a committee chaired by Carl Sagan. And those 116 images are these. I'm just showing you a preview of some of them. There's some math, there's some, spectra, there's images of the moon, and then we get into a tour of our civilization at the time. These are all images that could be the longest lasting records of our civilization. And that is because the Voyager probes are now in interstellar space, where the ambient particle density is on the order of a proton per cubic centimeter. And what does that mean? The structures of these probes themselves will probably last for billions of years, right? Because the structural integrity of the probes, unless they crash into something, the chances of which are unbelievably low, are limited by the lifetime of the half-life of the elements that comprise the structure itself, right? So just think of these probes as the oldest artifacts of our species. They're in interstellar space and will survive for billions of years, and they will outlast humanity for sure, and perhaps even the Earth itself, right? Because our star will one day start to shed its envelope, and the Earth might not survive that process. Don't worry, that's billions of years from now. You don't need to worry that much. So I want to end with this, which is my actual favorite image. This is a real image of our solar system taken on February 14th, 1990 by Voyager 1. It had been traveling for several decades out of the solar system. It looked back and took this image. It's old technology. This is slow scan Vidicon technology. So it's a little bit cruddy looking, right? But there are these two enhancements that you see on the left-hand side, and I'll zoom into one of them. This is just zooming into that image with some color enhancement. And this is the most distant image of Earth ever taken. This is the famous pale blue dot image, of course, that Carl Sagan very eloquently wrote about and spoke about. And that tiny little dot in there is the Earth from 4 billion miles away, right? So I need to wrap up because I don't want to take too much of our time, but I do want to now frame this in our, so here's our solar system, right? This is, Voyager also took a full family portrait of our entire solar system. So this is it. It's a composite of multiple images, of course, but all of the major inner planets are in there: Jupiter, Earth, Venus, Saturn, Neptune. But I want to frame that in the scale of the known cosmos, right? So how far have we ever actually stepped out? Well, to answer that question, I'm going to skip this part in the interest of time, and I apologize, Mary. I am wrapping up. I'm going to skip this part. This is just meant to give you some scale reference. You know, there's Earth and Jupiter and our sun for scale. And then here's comparing our sun to larger stars in our galaxy, large so-called O stars. So our sun is actually really tiny compared to some of the larger stars in the galaxy. Remember that our galaxy is a swirling void of about 200 billion or so stars, right? And so this, of course, we can't take a picture of our galaxy because we can't travel far enough to take a picture outside of it. But this is, our galaxy would look something like this to some alien civilization in another galaxy. And to give you a reference, the Voyager 1 probe, which is the most distant human-made object, has traveled 1 millionth of a pixel. Voyager has traveled about 22 light hours, almost 1 light day, since 1977, right? It's 2021. And this is every star you see in the night sky. I'm gonna wrap up by sharing with you. This is of course the Hubble Ultra Deep Field. These are not stars here; these are galaxies. So these are swirling kingdoms of hundreds of billions of stars each. And I will show you just now to end, Mary. One more minute. This phenomenal video put together by our colleagues at another museum, the American Museum of Natural History. It's a little bit old, so it's slightly outdated. They're working on an actual better one, and I think you should share it with your students, but this one is available now, and I still think it's phenomenal. And we're just gonna zoom out in some impossibly fast alien spacecraft to again give you a sense of the scale of the cosmos and the scale of how far we've traveled, right? So all these lines you see are artificial satellites. There's a lot of junk in orbit, a lot of it, trust me. We're adding more every day. It's a problem. But also enables GPS technology and a lot of important things. We're coming up on the orbit of the moon around the Earth. There's the moon. So now we're leaving the Earth. Now we're traveling impossibly fast, really, really, really impossibly fast, now faster than the speed of light. But just imagine we're in some magical spaceship. Here are the inner planets: Mercury, Venus, Earth. We're zooming out. We're getting faster and faster and faster. Our spaceship is accelerating logarithmically, right? So we now are 1 light day from Earth, about the distance that Voyager is from Earth right now. This is the scope of our farthest radio signals. You're going to see that in a sort of green bubble right now. Now we're going really fast. You start to see the local neighborhood, the local stellar neighborhood, stars near us, including Alpha Proxima, 4.2 light years away. There's extent of humanity's first radio signals. And now you see where we are in the context of the disk of the Milky Way, 30 kiloparsecs across. So that's almost 100,000 light years across. This is the local group. Now, this simulation, of course, doesn't show actual images of the galaxies. It shows a green dot representing each galaxy. But remember, each of those green dots and colored dots is hundreds of billions of stars and even more planets, right? So these are the galaxies we mapped so far. The universe is not shaped like an hourglass. It's just that we can't map galaxies in the disk of the Milky Way because of extinction by dust. I could explain that more in the questions if you want, but this is not the actual shape of the universe, but these are real maps of actual objects that we know exist in the universe. And now we see the most distant thing in the universe, the thing at the beginning of time itself, because remember, looking deeper into space is looking deeper into time, and that is the cosmic microwave background. And I've gone way over my time, and I apologize, and I will end there.
Wow. Well, that was quite a tour, Grant. Thank you so much. And I want to encourage people listening that if you have questions, or please put them in the question area at the right of your screen, and we'll get to those at the end. But the thing I really liked about your tour, Grant, is I actually do feel more connected to the cosmos now. I have a mentor, my former mentor at the Smithsonian, who always pointed out some people, when they see that scale and think of humanity as that little dot, think, oh, the universe is so vast and we're so small. But another perspective on that, I mean, that in some ways that's a good perspective to have. But the other, if you flip that around, our gaze fills the universe. We're able to look all the way out to the edges of the observable universe, and your tour just kind of spreads out the magnificence, which I think helps find a connection. Anyway, so we had this wonderful tour of all these objects in the universe. My role at the observatory is actually not as a scientist, but as an educator. And I work with an amazing team that includes Erica and others who help build tools and resources for teachers to help their students reach out to the edges of the universe in the same way that Grant does. And one of the tools I really want folks on the session to know about is called Micro Observatory. It's a network of 5 small automated telescopes that you can control over the internet. They are free to use. And in fact, what we try to do is take the inspiration of astronomers like Grant and provide ways for students to get that same inspiration. These telescopes, if you go to microobservatory.org, in fact, you could do it right now while on your phone and request an image using the Observing with NASA portal. And one of these telescopes that's out in the field, they're in Arizona, Cambridge, and we typically have one in Chile in the Southern Hemisphere, but it's actually coming back to Cambridge for repair at the moment. It'll be back online in a month. You can take an image yourself. And the nice thing about this resource is there's a big dynamic range. Elementary kids can take an image of the moon every night and investigate the phases. You can take images of those distant galaxies and explore size and scale. You can even make your own color images using the same techniques that professionals use, and there's lots of support for educators in using these resources. So one of the things we do is develop tools and resources, but Erica is going to tell you about the other thing we do with these tools and resources.
Absolutely. So Mary said she's an educator, but I'd like to point out that she's also a researcher. And that is one of the other things we do at the Center for Astrophysics in the Science Education Department. So our department has developed these great resources like Micro Observatory, but we're also focused on uncovering what works in science learning experiences. And so by that we mean what STEM experiences engage underrepresented youth, what builds science identity, what builds career interest, and what helps educators to be successful in helping their students with these things. So we're currently working on one such project called Youth Astronet, or the Youth Astronomy Network. It's an inclusive community of students, educators, and scientists exploring the universe with that Micro Observatory Telescope Network. I'm really excited to announce that in the upcoming year, we'll actually be recruiting middle school educators to participate in this ongoing research. And we hope some of you will actually be those educators with us. So to give you a little bit more context of what this program and research looks like, I'm going to share a short video right now.
With Youth Astronet, a program to teach astronomy through digital astrophotography, we strive to capture the scientific wonder all children feel, with a particular focus on cultivating the science identities of girls and minority youths. Youth Astronet succeeds because success depends on the people involved. We have the facilitators and educators who run the program. We have the team at the Smithsonian Astrophysical Observatory who provide continuous support. And of course, we have the students. There's still a few considerations to address if we want to help build science identities. First, how do we prepare and support educators? Most of our participating educators don't know much about astronomy or astrophotography to begin the program. To get ready, educators join us for live training webinars, office hours, and one-on-one tutoring. we take them through the ins and outs of our image capture and digital processing tool. Second, how do we get sustained engagement from the kids? Well, the experience is creative, it's meaningful, and it's real. The technology is real, the photos are real, and the editing and analysis are real. Students across the country access their unique workspaces in the Youth Astronet portal. Here they place requests to our telescopes to take pictures of various objects in the sky.
And then we process them. So we colorize them and we put in different filters to see the desired effects.
The students then must analyze the embedded information, the same way real scientists at Harvard and Smithsonian do every day, many of whom offer to serve as mentors and answer questions from the students.
Is it possible for humans to live on other planets? Have you worked on any robotic creations? How are stars ripped apart by black holes?
Among all this real
Will the
science
Earth
and
get
technology,
something?
students can get really creative.
I took 3 images of the Orion Nebula and I added a filter to each of those images. So I added a red filter to one image, a green and a blue to the others. And I was able to align them perfectly so it looks like the real thing.
Eventually, the students and educators together decide how to present their portfolio of work in a capstone project. Every student creates something substantial that lasts long after the program has ended. This is a piece of work that demonstrates their new mastery of astrophotography, and it gives them an opportunity to imagine their own place in the world of science. The final consideration: how do we know if the program is achieving our stated goals? Well, first, we conduct pre- and post surveys with the students of every program. Second, we observe how students are interacting with the Youth Astronet portal. In many cases, students use the website outside of program hours in their free time. Third, we talk to the participants themselves.
I think being an engineer would be cool now. Like I said, I did not like space, and now I think it's really interesting and cool.
But there's still more to discover out there, and I'm curious to learn more.
I would like to give a shout out to my mom for letting me do this program. I really enjoy it.
All right, so hopefully you enjoyed that video, and hopefully we've excited you to maybe think about our Youth Astronaut program and Micro-Observatory. So when we started this presentation, I'm guessing that maybe a few of you felt astronomy seemed a little impersonal or remote and irrelevant, and perhaps think your students have thought the same way. But hopefully through this presentation, we've changed your minds on that and made that not true, that you've found your own personal connections to the night sky. So we found that we've gotten some of our greatest ideas from working with educators like you and particularly in helping make topics relevant to your students. And so right now we want to know, what are some of your ideas on how you might make an experience like using online telescopes to take pictures of space relevant to your students? Or how might you engage your students in using these resources and learning about the universe? So we've shared in the chat box another Padlet, and we're asking you to kind of contribute these ideas to us as well. And while you think of how you might do that, I think Mary's going to answer a couple questions for us that we've seen in the Q&A.
Yeah, definitely give us your ideas for engaging students using robotic telescopes. But a couple of questions have come in. One is, how are the Micro-Observatory telescope locations selected? Massachusetts, Arizona, and Chile. These are actually all sites that the observatory has some connection with. They're all, the Massachusetts site is actually on the roof of the building where our offices are. So it's at the Smithsonian Astrophysical Observatory, the Harvard College Observatory. It's right on the roof. The ones in Arizona are at the Fred Lawrence Whipple Observatory, which is a Smithsonian observatory where many of the scientists use a giant telescope that's out there, the MMT, and there are other telescopes out at that facility. And there are 2 small telescopes at that Micro-Observatory telescopes there. And then Chile, the Cerro Tololo Observatory has a project from the Center for Astrophysics to study exoplanets. And it's a set of robotic telescopes that the professionals use studying, it's called M-Earth. It studies Earth-sized planets around cool stars that are called M stars. And there's this little building, and right outside of it sits one of our Micro-Observatory telescopes. So that's how we choose those. It looks like know if people are adding to the Padlet yet, but I'll answer the other question, which is a great question. Are there any common misconceptions that we find students have about the universe? What myths should you help bust? I think that's a very common misunderstanding that kids have is, they learn all this jargon from movies, galaxies and stars and planets and names of planets and black holes and white dwarfs and red dwarfs and all these. And so in their mind, their mental model is often that all these things are kind of thrown out there in a big, just mixed up everywhere. And the fact that the universe is actually organized in these hierarchical clusters. There's the Earth that's part of the solar system, that's part of the galaxy, Milky Way galaxy, that's part of the universe of galaxies, and all these amazing shapes are all kind of shaped by gravity, and then lots of other forces in the universe. So I think the key things in learning astronomy are some of these big ideas that help kids organize a lot of what they're learning. Let's see.
I'm seeing someone answering it, joining our Padlet here, talking about stories inspired by the local night skies. And that actually makes me think of our collaboration with the Abbey Museum in Maine, who's been developing a program using our microobservatory telescopes to tell the star stories of the local indigenous peoples. And so we're actually really excited in the next year, we'll be able to share that curriculum with you. We've been working with them to partner on how you might take your own local star stories and do a similar project, but with stories to your communities. So yes, I love that idea. And we're so excited to be able to share some of that with you in the coming year. All right, we've got 2 minutes left. We've got one more question in the chat, but I also want to make sure we put up on the screen and in our chat opportunities for you to stay connected with us. So we're going to put in the chat an opportunity for you to get all of our microobservatory announcements and the other exciting research that we do in the science education department. So please go there and fill that out. We'll be sure to keep in touch, and then follow us on Twitter and Facebook. You can also follow the Center for Astrophysics itself on Twitter at Center for Astro. Mary, do you want to?
Yeah, let me take that
on this
question
last question.
How to connect collecting images from telescopes to music without sacrificing the scientific integrity. Well, I never very upset about scientific integrity when it comes to integrating other disciplines. I think that's always a wonderful thing. I'm going to point out there are lots of sonification. If you Google sonification, in fact, at the observatory, the Chandra group has developed some sonifications of images from NASA telescopes that are really wonderful. And you should definitely look at those. That's kind of a nice way of integrating music, and I think Grant has something too.
Yeah, I wanted to pitch our sonification effort. I think that's just a phenomenal effort. We don't have a link handy, but if you just Google Chandra sonification or even NASA sonification, you'll find it. It'll be the top result, definitely. I also wanted to point out that there are so many beautiful connections between music and the cosmos that are real, that don't sacrifice scientific integrity. One of those examples, and now that we have this great question, I wish that I had the image, but I don't have it now and I don't have time to pick it up. But in a local cluster called the Perseus Cluster of Galaxies, this is one of the largest gravitationally collapsed collection of galaxies in the local universe. This cluster of galaxies is sitting in a bath of ambient plasma, and at the very center, yes, Erica?
I think we have to say goodbye.
Oh, we do? Oh, no. Google
time.
Perseus B flat. Google Perseus B flat, and you'll find it.
Thanks to everyone who joined us. And I I will hope you all feel more connected to the cosmos.
Thank you all.